Standard 3.6, solve trig equations that involve more than one trig function. All right, so for our first example, if you take a look, we have both cosine and sine in our equation. This is not going to be possible to solve until we convert everything to sines or everything to cosines. Now, if you look on your identity sheet, we have an expression for cosine squared. In the Pythagorean identity box, you can see that cosine squared is equivalent to 1 minus sine squared. So let's do that substitution now. Let's replace cosine squared with 1 minus sine squared x. And let's bring on the rest of the problem. So just to color code, what's in yellow here is equivalent. The rest of it we are bringing down. So minus sine x equals 1. Now if you notice, this is a quadratic trig equation because of that exponent squared. So we're going to let y equal sine x. And let's rewrite the problem. Our problem is now 1 minus y squared minus y equals 1. And to solve a quadratic equation, we generally want to set it equal to 0. It's nice to have y squared positive, so I'll bring everything over to the right side. Add y squared, add y, and subtract 1. And we get 0 equals y squared plus y. We can factor this equation now. Notice that there are two terms and they both have a y in common. So we can factor out a y, and we're left with y times y plus 1. Think about it as reverse distributing, right? If you distributed the y back in here, you get y squared plus y. All right, so now we have two factors. We're going to set each of them equal to 0. So y equals 0 and y plus 1 equals 0. And that makes y equal to negative 1. Keep in mind though that y is equal to sine x. So let's put the trig back into our equation and replace y with sine x. We get sine x equals 0 and sine x equals negative 1. So sine x equals 0 is quadrantal. Sine is the y coordinate. The y coordinate is 0 in these two locations. Let's put our restrictions between 0 and 2 pi. So let's say that we want our answers in radians. And so we have 0 as one solution and pi as a second solution. Sine x equals negative 1 is also quadrantal. Sine is negative 1 down here at the bottom. And that is at 3 pi over 2. So our third solution is 3 pi over 2 for x. That's standard 3.6, solving trig equations that involve more than one trig function. Let's look at one more example. Let's say, for example, that we have the following equation. Sine x cotangent x minus sine x equals 0. Now, in this equation, there's no quadratic. We have two different trig functions, and we can replace cotangent with cosine over sine, but then we're introducing another trig function of cosine. So we have to think about another way that we can work with this equation. Notice that there are two terms here, and both of them have a sine x in common. So in this particular equation, we can factor sine x out. Factoring sine x out gives us cotangent of x minus 1. Again, think of reverse distributing. If I distributed the sine x back to the original, back to this problem, we would get the original problem again. Notice that this is now in factored form. So you can set each of your factors equal to 0. Sine x equals 0, and cotangent of x minus 1 equals 0, which gives us cotangent of x equals 1. Now sine equals 0, we already saw from above. It's quadrantal, so there and there. Let's put our restrictions between 0 and 360 for this particular problem. And so at 0 degrees and 180 degrees, sine x equals 0. On the other side, we have cotangent, so let's change it to its reciprocal. Tangent of x equals 1 because the reciprocal of 1 is 1. For this particular equation, Our reference angle is 45 degrees. If you look at your note card, tangent of 45 is 1. Since 1 is positive, our solutions lie in quadrants 1 and 3, where tangent is positive, and the quadrant 1 solution for x would be 45 degrees, and the quadrant 3 solution for x would be 225 degrees. So we have 4 solutions in this example. That is standard 3.6.